Happy Tuesday, everyone. This is Miss Allen, and today we are looking at scientific notation, real-world applications. Our goal for the day is to be able to use scientific notation to solve real-world problems involving very large and very small numbers. To do this, we're going to use the scientific notation operations that we already know. So at this point, we should be very familiar with addition, subtraction, multiplication, and division. We're going to use these to help us solve some real-world problems. And we're going to talk about some things to be careful of. The biggest thing is that we want to read our questions closely. The question will tell you what operation to use, typically. I do want to add, if I'm writing it down, it probably needs to be in your notes, so make sure that you're getting these. I just want to point out one specific example that seems to come up very frequently. As I was working through and reading through problems, this phrase in particular, and this is why we say to read the questions carefully. So if we have how many, if the question says how many, or how many more, sorry. If it says how many more, that phrase tells us to subtract, but if it says how many times more, and I'm going to underline the times there because that's the part that's different, or how many times greater, that is always divide. Make sure you get those written down. Those are important. Okay, so we're going to start with some addition examples. And even though we know that these are addition because they're listed that way, we're going to talk about why and how we know they're addition as we work through them. So example 1 says, a curse so dark and lonely is 5.64 times 10 squared pages long. The sequel, a heart so fierce and broken, is 4.64 times 10 squared pages long. If a student reads both books, how many pages would the student have read total? So we want to focus on that question, and I'm actually going to start with this part. How many pages would the student have read total? So for me, this word total is what clues me that I need to add those two numbers together. So I want to add 5.64 times 10 squared plus 4.64 times 10 squared. When we're adding in scientific notation, the first thing that we need to look for is to see if our exponents match. So I have 10 squared and 10 squared. So that means that I can add these as they are. I just need to group my lead numbers together. So I'm going to add 5.64 plus 4.64, and I'm going to keep the times 10 squared. When I add those together, I get 10.28 times 10 squared, but we always have to look at the end and check and make sure that we are still in scientific notation. So I look at this number, 10.28, and I realize that that number is larger than 10. So I need to move my decimal place, and when I move it to make this number smaller, that means that I need to make my exponent larger. So that means I need to add 1 to my exponent up here. So my new number in scientific notation will be 1.028 times 10 to the third pages. So if the student read both of these books, they would have read 1.028 times 10 to the third pages. Example 2, like I said, we also know that this one is an addition problem, but we're still going to work through it and figure out why. So it says the distance from Mobile, Alabama to Memphis, Tennessee is 3.9 times 10 squared miles. The distance from Memphis to San Francisco is 1.2 times 10 to the third miles. If you travel from Mobile to Memphis, then Memphis to San Francisco, how many miles would you travel altogether? So, again, I can see that we have two different sets of miles, and this word altogether is my keyword that's telling me I need to add these two numbers together. When I go to work this, I'm going to put 3.9 times 10 squared plus 1.2 times 10 to the third. To be able to add these, I need to make sure that my exponents are the same. So I have 10 squared and I have 10 to the third. Well, those are not the same. There are two different approaches to solving when we have problems like this. I'm going to choose to convert these to standard form, add them together, and convert them back to scientific notation. Since this is 10 squared, I know I need 2 decimal places. So that means I need to have a 0 right here to be able to move it 2 places. So we move 1, 2, we can count them 1, 2, and we get 390. This time I need to move 3 decimal places, but I only have 1, so I would need to add 2 zeros this time to move 1, 2, 3 places. So I have 390 plus 1,200. And you can see the decimal was here, and it moved 1, 2, 3 places. So I'm going to add these two numbers together. 390 plus 1,200. And I get 1,590. And our units are miles. This is a good usable unit here, but since we are working on scientific notation, we do want to put this back in scientific notation. So this becomes 1.59 times 10. 1, 2, 3 places. So times 10 to the third miles. Okay, moving to our subtraction problems. Again, we know that these are subtraction, but we want to make sure that we look at the question and think about what it means and why it tells us to subtract. Example 3 says 8.73 times 10 to the 8th people in the world speak Chinese. About 3.22 times 10 to the 8th people in the world speak Spanish. About how many more people speak Chinese than Spanish? So for me, this how many more, and even though it says more, that's telling me that I need to find the difference in those two numbers. How many more means what's the difference in the two numbers, and difference leads us to subtraction. So I'm going to take my two numbers and I'm going to subtract, and we want to know how many more speak Chinese than Spanish. So I want to subtract the number that speak Chinese. Take the number that speak Chinese and subtract the number that speak Spanish from it. So we have 8.73 times 10 to the 8th minus 3.22 times 10 to the 8th. same as with addition, the first thing we want to look for is the matching exponents. We do have 10 to the 8th for both, so I can subtract these numbers as they are. So I want to do 8.73 minus 3.22, and I'm going to keep my times 10 to the 8th. So I subtract here, and I get 5.51 times 10 to the 8th. And the question is about people. So we have 5.51 times 10 to the 8th people. More people speak Chinese than Spanish. That seems like a lot of people. If you think about this exponent of an 8, that means there's going to be a lot of people in that problem. Example 4, it says, in 2006, about 1.9 times 10 to the 7th people visited Blue Ridge Parkway. That same year, 9.3 times 10 to the 6th people visited the Great Smoky Mountain National Park. How many more people visited Blue Ridge Parkway than the Great Smoky Mountain National Park? Okay, again, we have that how many more. Okay, that one was marked on our first page in case you forgot as one of those phrases to watch closely for. It does just say how many more, so we want to know the difference in those two numbers, and difference tells us to subtract. So I have 1.9 times 10 to the 7th minus 9.3 times 10 to the 6th. So I have my Blue Ridge Parkway people minus my Great Smoky Mountain National Park people. So I look at my exponents, and this time they're not the same. Okay, this time they're not the same. So I do need to convert them to be able to work it. I'm going to choose to convert this to standard form. If you like to leave them in scientific notation and make your notations match, you can work it that way. I'm going to convert them to standard form. So this tells me that I need to move 7 places. I have 1 space, so I'm going to need 6 more zeros. So 1, 9, 1, 2, 3, 4, 5, 6 zeros. So if I started here, I moved 1, 2, 3, 4, 5, 6, 7 places. I'm going to put some commas on there to make it just a little bit more user-friendly. I'm going to do the same thing with the 9.3. I need to move 6 places. I have 1 decimal place taken care of, so that means I need 5 zeros. So 9, 3, and then 1, 2, 3, 4, 5 zeros. I'm going to put some commas in again to make it a little bit more user-friendly. And then I'm going to subtract. Okay, when I subtract these, I get this number. I'm going to put some commas on there to make it a little bit easier to read. So we have 9,700,000. We know this is people again, but we do want to put it back in scientific notation. So we have 9.7 times 10, and we'll find our decimal place. We'll count our places to find our exponent. 1, 2, 3, 4, 5, 6. So times 10 to the 6th people. So this means that 9,700,000, or 9.7 times 10 to the 6th, more people visited Blue Ridge Parkway than the Great Smoky Mountain National Park.